In the last lesson, we examined how the internet works and the general flow of data packets. Now we can take a look at the mechanisms that allow or restrict the movement of these packets using network routers, firewalls, and port configurations. We'll start with local area networks. A local area network is best described as a group of computers that share a common communications line within a relatively small area. A LAN is typically confined to a single room, building, or group of buildings. Let's explore how a LAN is formed and some important considerations. To illustrate the structure of a local area network, we'll start with the most basic network configuration. When we first sign up for internet access with our local ISP, the ISP issues us a modem. This modem is connected to our ISP using a coaxial cable or DSL phone line. This cable connection allows us to transmit data packets over the internet, as we learned earlier. Technically, we can now take a computer and connect it directly to the modem using an Ethernet cable. In this case, the IP address assigned to the modem by our ISP would resolve directly to our computer. We're now connected and can send emails, browse the internet, and transfer files. This is a great start, but there are some important issues we have neglected in this type of setup. The first major issue is security, and the second is network expandability. First, our computer's operating system, whether Windows, Mac OS, or Linux, is a very complex software with many applications. It's open to security vulnerabilities that can be exploited over an internet connection. Hackers commonly look for security issues in software and exploit these vulnerabilities when found. By connecting directly to your modem, hackers can transmit data requests much more easily to your computer and determine if any vulnerabilities do exist. We'll explore this in more detail in the next lecture. Secondly, say we wanted to split our internet connection so that 2 or 3 computers and other devices such as printers and mobile phones can simultaneously be connected. A modem only allows a single Ethernet cable or DSL line connection. In order to split the connection, we would need a router. By connecting the modem to a router, all devices connected to the router can access the modem, and therefore the internet. The router provides a local unique IP address to each connected device, though they would still have the same external or public IP. The router would then analyze all data packets traveling through the network and direct them to the appropriate locations, whether within the LAN or destined for the internet. This diagram provides an illustration of different files transferred over the network. When John sends an email, the router directs the email to the wide area network for outbound delivery. John has also sent a print job to a printer attached to the network through the router. The router knows to keep the data packets associated with the print job within the local network. It sends the packets to the printer for output. Bob receives an incoming MP3 file transfer, and the router directs the file to Bob's computer using his locally assigned IP address. Kim is browsing the internet, and the router is directing incoming and outgoing HTTP requests to Kim's web browser. Sue's tablet is connected to the router through Wi-Fi. The router has assigned Sue's tablet a local IP address just like any other device. Since Sue is on the internet using Facebook, the router is relaying HTTP packets from Sue's web browser to Facebook's web server. WAN, or Wide Area Network, is simply a more complex network that spans across much larger geographic areas, such as cities, states, and nations. We've already discussed how vast the Internet network is and its global reach. Wide area networks are typically built by Internet service providers to provide connections for local area networks of their customers to the Internet. Since the Internet is a worldwide network of interconnected computer networks, it's the largest WAN in existence.